Okay guys, welcome back. So today I'm going to show you how to create contour map and HillShade from that DEM data we already have, right? We're dealing with DEM data, that is the raster data. We already projected this DEM from geographic coordinate system to state plane, and you already have how to create flood inundation map from DEM data. So now we're going to see how to create contour map, and after that we'll see how to create HillShade, because if you have any hill tracks and if you want to see right the shaded area from opposite side of the sun, so it will show you some kind of shading, but for a flat land you won't be able to see that, since Texas is a kind of flat area, so we'll exaggerate the shading and the elevation data. We'll do that. So by this time we already have idea about how to convert the vertical unit, right? We had vertical unit as meter, so we converted it by multiplying by 3.28, so that's the conversion factor from meter to feet. So let me quickly share my screen and I'm going to show you how to do that. So far we are here, right? We already have this DEM that is in feet, DEM feet. So if I just stop, what I can see, turn this off, and if I just change the contour as this one, okay, let's see what we have. So that is the DEM data we have right now, right? So what we have to do, we basically have to create the contour map. So how can we do that? In order to create contour map, the main option we have here, these are the spatial analysis tool, and if you are familiar with spatial analysis tool, so that is the option. If you are new, so go to customize and extensions, right? Extensions, and click all this thing, turn this on, then you'll be able to see. If you click on arc toolbox, and from the arc toolbox you can go to there, right, spatial analysis tool, because we are working on raster, so most of the time we'll use spatial analysis tool. And here, since we are going to create something, we already have idea about map algebra, we already use that raster calculator. Now since we are gonna create a contour and it is related to surface, right? So find the surface where we have, that is the surface, okay? And from that surface you will see different types of values you can calculate here. So you can calculate contour. So this time I'm gonna calculate contour. Contour is the line that is basically elevation map, so it will cover either, it will follow only the elevation. If we assign 10 meter or 10 feet elevation, it will only follow the 10 feet, okay? And then it will have a certain offset from one control line to another one, and one control line can't even intersect with another one. So these are the rules we are going to follow here. So input raster, so that is the raster we have, DEM feet, because the elevation we are using here DEM, and the contour interval we are going to see 10 feet interval contour, and the base contour. So we see from that see color bar, the minimum is minus 22.96, right? So the minimum value, if we use 10 meter 10 feet contour, so that will be 20. So the minimum will be 20, right? And what will be the zonal factor, right? For this case, zonal factor is 1. If your vertical unit and your horizontal unit is same, for this case it is same, because previously we had a meter as vertical unit, but this time it is feet, and the horizontal unit as feet as well. And the contour, right, it is kind of contour, and then okay, we are okay with that. And now I'm going to save that. Where I'm going to save that? Lab 2, but I'm going to save it as contour DEM, okay? And feet, contour DEM feet. Let's see, not this feet, that way, okay? If I click OK, so it will create that contour. See, it's working. You can see that background processing is happening here, creating contour, right? You can see that at the lower right corner. And once it's done, it will show the contour lines. See, it's pretty fast. See, we can see the contour lines. If I turn that off, and we can see these are the contour line, because we use 10 feet, right? So these lines are basically separated by 10 feet. So these are the contour lines. It is kind of mismatch, but see, if we just zoom in a little bit, you will see these lines are really, see, this way. These are the contour line, because the DEM is kind of so flat and it is showing that way. It is even covering the river, right? So that's why it is like this one. And if you want to even, okay, let me right click and change the symbology, and you will see it is changing. And then go to symbology, and this time not single symbol, quantities, and then a graduated color. And if you click on that value, contour, okay, this contour, and then it is giving us these values. The minimum value is 0, but 0 to this one, 0 to this one, and 150. But our minimum value should be minus, right? So we can change that. Okay, let me delete it and do it again. Maybe we shouldn't specify that one correctly. Okay, so that should be contour interval is 10, and the base one is minus 20. Okay, and G factor is as it is. And now this time let me show you what is happening. Okay, maybe pretty quickly it is going to create everything this time. Yeah, that's why you have to even try by trying this option and that option, and you will learn new thing. If I turn this off, this one, so now we have this one. See, it is more visible, right? It is starting from minus 20. Now if I go to properties and then symbology, quantities, and graduated color, if I select contour, okay, now I have these values this way. And if I just use 10 different values, and if I use this as integer, right, then it will look good. And if I select this color, okay, for the time being we can select this one, not a problem. This is kind of contour. Okay, so that is the contour map. So if I want to create even HillShade, so what will happen? Same thing. If I turn this off, if I turn that DEM on, go to ArcMap, instead of contour, this time we have to even select that HillShade, double click on it, and then input raster, same way, input raster, and then azimuth angle is by default 315, and altitude, because it is kind of create, right, a shade on the opposite side of the hill. If we have one obstacle or any mountain, what will happen? If we have sun from the west, so it will create shadow on the east side. Okay, so the zonal factor is, since the Texas is kind of flat land, if we want to see, right, Z factor is 1 if our vertical and the horizontal units are different, right, are same. For this case it is same, that's why it's 1, it's the true. But what we are going to do, we are going to just exaggerate the factor. Okay, we are just making 20 times. So if the horizontal unit is 1, so vertical unit, it will multiply by 20, and then there will be a difference, right, in elevation. So we can see maybe it is gonna look like kind of mountain, and then it will create some kind of shade. It is possible. Okay, or I can even use 50. Let's see what it's gonna show. If I, okay, put it as it is, and let's click OK, and let's see. Maybe this time it's gonna show you something different. See, that's the HillShade, and for this one set it's gonna create 0 to 255 different values, right? And if you select different color, color means a way, such a way that will create kind of shading. I don't know which color will show you that kind of shade. Maybe, okay, that is the color, or I can even select this one as well. It is not a problem. Okay, and I'm turning this on as the same at the same time. And what I'm gonna do, oh, these are the same, so I'm gonna change it to okay, that is okay if I keep it that way, and right click and property, because I'm gonna make transparency there, display. Okay, here brightness, transparency, if I use 60%, and let's see if we can see any shadow. Can you see that? definitely we can see this is the river, right? This is the deeper portion, and we have highest portion, and we can see the shadow there, right? That is the shadow, and we call it HillShade. And we can see the river. If I wanna see the landscape mode, I'm starting from the beginning, that's why I have to change it to that way. And if I fix that, so every time if I create something, I just create the map. That is the ultimate goal we need to even create, right? Because in order to display something, we need to create the map. So you'll be able to create map frequently, and then if you want to fix it or right click on that one and go to that zoom to layer, it will be that way. If you want to even add the base map, go to plus sign and then click on that add base map, and you can add anything you want. Okay, you can add that light gray canvas, street map, topographic. I'm gonna use that topographic or train with level this time. Okay, let me use that one, so maybe it is gonna look different than what we saw previously. So it doesn't matter. Okay, you have to just test with different types of maps and you can see which one you are gonna fix. Okay, yeah, it's nothing new, it's as it is. Okay, so what we are gonna do, that can you see that it is connecting the lakes and that Galveston Bay pretty nicely, and you can see the shadow, right? We can pretty quickly see that. And what I'm gonna do, I have to insert that legend. We can do that definitely. Yeah, we're gonna insert that legend. This time I'm not gonna give the name because we know it is legend, and I'm adding that. Okay, and here it is. If I wanna even double click, and if I wanna select everything, I can change the color, I can change the name on bold and the type or this one. Okay, and that's it. Okay, even you can drag it, you can make it smaller if you want. Anything it is possible. And then if you want to add like north arrow, you can do that as it is. Many times we saw this. Okay, you can drag it and you can make it bigger. You can see that it's there. If you want to add that scale bar, we can add it. Okay, here it is, and you can put it there. It is in feet. See, now it is in feet. Even you can change it to mile. Double click on it and there number and mark, and you can see format. These are the symbols we have, and frame you can change it. So what will be the value? It is feet. I'm not gonna show that right as feet. I'm gonna select mile. Okay, miles instead of feet. Okay, now it is good. Okay, and I can even change it to bold and see the number, and you can increase, and you can increase the format or size. It's bold, anything is possible. Okay, yeah, see, it's pretty visible. You can even manipulate anything you want, and even you can add the title. That's the thing we can use. So HillShade. Okay, HillShade map of San Jacinto watershed. Okay, that's the map I'm copying because I have to change it. It won't be that big. I'm pasting it there. I'm gonna change it to 22 or 28 and make it bold, and let's see. Okay, now it's visible. See, if I want to even export it as before, we can do that. See, that's it. I'm gonna save it to, okay, my default directory in download, so that is the HillShade. Okay, HillShade map. If you increase the resolution, use 300, that's it, and it is exporting the map as well. So far we have already learned, right, how to download DEM data and how to transfer the unit, and we also already demonstrated how to convert the coordinate system from one coordinate to another one, the projection system, and everything we did, right? So you can practice by yourself, and that is, I think, very important thing to know. We can do even many processing. We already calculated the inundation map, we already calculated the control lines, we already calculated the HillShade, and we know how to use that raster operation, right? We already have idea about that one. If you just use your raster calculator, you can even convert the vertical unit, you can convert even anything, even you can calculate different, right, areas and volumes. We already have idea about that one. We calculated the volume of water storage, and we calculated the area as well. If you know the cell size, you can calculate the area, and we already have idea about how to calculate area from any shapefile. So we know that, right? Once we have idea about everything, then what we can do, we can even move forward. So next time what I'll show you basically a different operation on the same watershed, because we have to create a model, HillShade model for this watershed. So if we know everything, right, every property, we know soil information and the topographic slope and any other information and the stream network, eventually we'll calculate the stream network. By this time you already have that, right, from NHD plus. But if you want to calculate by yourself by just processing your DEM the same way they processed it and they're just uploading this data, it is the same way. We'll follow that one. Okay, now we'll just calculate the cross-sectional area, and we'll calculate some cross-sectional volume from this raster calculator. We'll card the DEM. We can do different types of operations. So that is our ultimate goal. And out of this DEM and the study area, we'll create a hydrologic model HillShade, and we'll follow one stream, most significant stream, to create our HillRAS model. Then you'll see we can integrate all this thing all together. So that is our goal. So you can try by yourself and let me know if you have any problem. I don't think that you're gonna face any problem, because these are pretty simple and straightforward step. If you just follow what I just did, and if you just do for the first time, you may face different type of problem. Since I am doing this thing for the long time and I know how to solve this one, and I'm just clicking the right way. You may click separately, then you may see different types of problem or arising. Then you can even search for it and you can learn new things. So that's it. I'm gonna finish off here, and later on I'll move forward with different topic. So stay safe. Thank you for watching, and see you in the next tutorial.